Hi everyone. So, welcome back to another lecture in mathematical methods. Today, we are going to look at the second derivative. Okay. Now, what that is and how it is important to us, how it's relevant to the course, all of that we'll discuss in due time. Derivative, not derivate. I don't even know what that means. Okay. Derivative. Okay. Very cool. Very cool. So, um, let's just get right into it. So, say you have this function, okay, and so long for this whole time, okay, we have a function, and what we've been doing is we differentiate it, okay. So we put that function through this process of differentiating, and we get this function, okay, which we call the derivative, okay. Clear to that? Very nice, okay. Again, it's not derivate, it's derivative. I don't know what I'm doing. Derivative. Okay? So that is your derivative after you differentiate it. All good. Now, who said that you have to differentiate only once? This process of differentiation, right? We can apply this as many times as we want. Okay? We can do that multiple times. Okay? So let's say you differentiate again. Okay, you differentiate one more time and you get something. Now, what would this be? It would be a derivative. Obviously, nothing that complicated. But in this time, again, what's it with the derivatives? Derivatives. All right, okay. So this time, this is not just any ordinary derivative. It's a derivative of this derivative here. Okay? That is an important thing. It's a derivative of a derivative. Okay. So that's a lot of words, you know. So instead, we have found a shorter way to say it. Because you get this derivative after doing the differentiation process twice or for the second time, we call it the second derivative. Hence, second derivative. Okay, that's what we are looking at. Similarly, you get this derivative after applying the differentiation process for the first time. Okay, so this is the first derivative. You can also think of it as this one comes first, therefore the first, that one comes after, therefore the second. Okay, so we got the terminology all good. Okay, so how do we notate it? You know, I'm big on notation and I emphasize it a lot. So how do we notate it? Well, when we go from a function to a derivative, we slap the dash there. Okay, when I go from a derivative to the second derivative, I'll just slap another dash there. Okay, so the number of dashes is equal to your derivative. Okay, whatever, if it's a second derivative, two dashes, blah blah blah. But you know, as you go and you do more and more different derivatives, although in practice you'll see you rarely ever use more than the second derivative. If you keep going, you know, and you get to like fourth or fifth derivative, it gets very impractical to just go dash 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 dash, you know. So instead, there's a shorthand way of writing that is you write f to x, and in brackets, you write what derivative it is. So this one, second derivative, you write the 2. If it's a 3 there, is a third derivative. Not very complicated. Okay. Now, you know, you don't only get the function as f of x, you can sometimes get it as y. Okay. What do we do in this case? Well, we differentiate it, okay, and we get dy on dx. When you look at that, all you really did was you took this, you added a d on dx behind it, and you got that. Okay. So when I do this process again, why don't I just do the same thing? I take this, all right, and slap the d on dx behind it. Okay. And that is what the second derivative is in this case. Okay. That is how you denote it when you have that sort of, when you start with y. Okay. That's how you denote it. So, how do you read this? Well, this is the derivative of the derivative of y. Okay? So this is the derivative of the derivative of y. Okay, again, basically the same definition. Basically the same definition we gave up here, but same problem. Very a lot to say. Also a lot to write now. So instead, well, we as lazy mathematicians, but accurate, lazy but accurate, what we do is we say, well, there's two d's at the numerator, so this becomes a d squared. It's kind of like multiplying them. You've seen this during the chain rule. When you do this sort of stuff, it kind of acts like fractions. So we can do this sort of stuff. And there's two dx's, and you can make like that, right? Write it like that. Now, accuracy goes out of the window when the notation then becomes this. This is the actual notation for the second derivative. Okay, it makes more sense to have the brackets there, but we don't. But just because of convention, but also because that's not how you really come up with it. Okay, this is just my way of showing an easy process to get to it. Whole process is different, different terminology and all that. But yeah, the important thing is the number here denotes which derivative it is. Okay, so if you have d3 y on dx3, that is your third derivative. Okay, simple stuff. We got our second derivative. Okay, we know how to denote it. We know what the names are. Very, very straightforward processes. Let's just practice it a little bit, to understand this notion of differentiating a second time. But my advice is to not overcomplicate it. It's literally just differentiating again. Okay. So if you have this function, for example, y is equal to x cubed plus 6x plus 10. Okay. You just differentiate once. Okay. dy on dx is equal to 3x squared plus 6. Not a very complicated function. And then you differentiate literally again. Okay. You take that, differentiate it, you get 6x plus 0, or just 6x. There we go. There is your second derivative. Like I said, not a very complicated process, but a rather important one. And you'll see that when we get more into the implications and how that tells us something about the function itself. Okay, but for now, this is all you need to know about the second derivative. What the notation is, how to get there, all that. So do some practice problems, okay? Get very good at getting the second derivative because it's going to be very important when I start talking about the implications and whatnot. So good luck, and I'll meet you in the next one.